Okay, let's go ahead and create another rule. We want to access that memory. We'll call this use memory. And we want to be affecting the red group. Let's go ahead and make another group. We're going to call this trail. And trail will make kind of a greenish color. So we want the red particle to look up in his memory, find his own memory data type for this position, whatever he had stored in it, use it as an output this time, and we're going to go ahead and use that output position with a position born for the trail. We're going to do pistol shot per call. We'll set lifespan to be, we should do the full time range 300, no speed, that's important, we don't want to move it around, and we're going to go ahead then and just use that position to pipe it into the position born. You know what, actually let's go ahead and set their direction to head off in the X direction, and let's go ahead and give them some speed. Let's give them a speed of 20, because we want to see if multiples are born. We just want to be able to tell how many particles are being created. And so now you can see what's happening is the red particles moving up there, and these green particles are being born as he travels. Okay, now what's happening is red particle is looking up the position information, and because no depth is specified, he's just using a depth of 0 by default to output this position. So it does not actually output the entire history array, all 99 levels of depth for this position value. It's just going to go ahead and use depth of 0 because nothing's specified here on this depth input. We're going to take a look at how to do that in a second. But so as the red particle moves forward, he's just going to look up the 0 depth value of his position and use that to create a trail particle. So on every new frame, it's going to born back where that particle was, his history. Okay, so just remember, if you don't use a depth input, it's going to specify 0. And in this case, it's only going to output the 0 depth, whatever he had stored just last. Okay, so let's take a look at how we can actually access the full depth range, because we want to actually see that depth being used. What we're going to do in order to do that is use the initiator, a very powerful one called iterator. And iterator is going to allow us to cycle through a count of values, and it will cycle through all in one time step. It's very powerful. There's a great sample scene, I think it's called Cube World, that makes extensive use of iterator. Definitely take a look at that. For now, let's go ahead, and what we need to know is that we're going to set our count to be 99. We could use 100 since we know there's actually 100 there. And we're going to go ahead and pipe that number into the depth. And let's go ahead and just scrub, and we'll see that it doesn't born any. Well, what you need to know is that iterator sometimes needs a particle value being fed into the on. And so that each particle is going to go ahead and iterate through all these values, all 100 values, and output this number every time. Okay. Let's go ahead and see now what happens. Now we can see, let's zoom in here a bit. You remember we had given these trail particles, the green particles, some speed during birth, so they kind of move away to the right. And you can see this edge here is where the most recent particles are the earliest born. And then what happens is it just repeats, emitting from that history position, continues to output particles, trail particles. So what's happening here is on every time step, let's go ahead and go forward just one, you can see that now this red particle has already stored 2 position memory positions. And so this iterator, even though he's going to go ahead and count through 100, it's really only the first two that are going to be valid. Everything else is empty so far in this memory. So it's going to go ahead and on frame 0, it evaluates, and it's going to store where his previous position was, which is right there. And then it's going to go ahead then, and when we step forward, it's going to go ahead and born another particle where that previous position had been. So if we want to know where the particle actually traveled, we need to look at this edge here where these particles are being born. Because you remember, we have position born, they're moving off in the x direction at some speed, but basically it's recounting, it's storing each of these position locations here along this edge, and then it's borning new particles every, one particle per call, so one every frame. It's going to born a new particle at that stored position and send them off to the right, because we've got that direction of x equals 1. Okay. Then let's go ahead and see, as he gets way out there, I'm going to go ahead and turn off the grid. What we'll see is that as soon as we pass time of 100, this back edge here, where particles used to be created, is no longer creating particles. And the reason for that is, we've passed frame 100 in time, and so he's setting a position value every time step, but he's only got 100 slots available. So as soon as he passes 100, he's going to have to start giving up these old ones stored down here. Let's see if we can get in there. So these ones are no longer going to be used, and they're going to be used for the positions that are being stored way up here at the new location. And so this would be particle depth 99 or 100 right now, but then on the next frame he's just no longer going to be creating any particles there. He's got to give up that memory slot, that depth. So just remember that you are limited to a depth of 99, 100 here with the memory operator. There's different ways that you can cope with that. You could actually have it update the memory, set the memory once every 10 frames or every 3, whatever. You can use probably a timer, or probably more so a counter for that. Take a look at the helpers videos for that and help file. Okay, so this is a little bit more complex version of memory. We've taken a look at how to store multiple depths into a memory slot. We know that each of the data types here, we can set anywhere from a depth of 0, which actually means 1 slot, to 99, which means 100 slots. And that's just an array, so it'll store up to 100 values for that one particle of this data type. So each particle can store his own 100 values for this. You can use that to keep a history of something, as we did here. You can use it, gosh, in a wide variety of ways, any way you can really think of. But just remember that if you do want to ever recall any range of depth, you're going to want to use the iterator, because this actually processes this whole count all in one time step. Okay, so let's go ahead and move on.